Hey, welcome everybody. My name is Dave Payne from Elastifile. Excited to be with you guys today. We'll be talking about POSIX file systems, enterprise class storage in Google Cloud. I'm honored to be joined by a couple of good friends here today. We've got Naidu Anamaneni from Elastifile, or from eSilicon.
Yeah, I am CIO responsible for strategy. CIO responsible for strategy, software development, IT operations at eSilicon.
Mm-hmm. Yeah, and Dean Hildebrand is joining us from Google.
Hello, my name is Dean Hildebrand. I'm in the office of the CTO, and one of my goals at Google is to make file storage awesome in Google Cloud.
That is great. All right, well, we got a few minutes together today. We're gonna jump into some high-level stuff, and then we're gonna get deep and go technical. I assume that's why you're here. With a title like this, if this is attractive to you, you're a hardcore nerd, and we thought we'd serve up some meat in this session today, okay? So let us get through a few slides of intro, and I promise we'll deliver some real demos in the middle of the section, and then Dean and Naidu are gonna stand up and share some of their perspective and real-world experience doing this in cloud, okay? So first of all, there's a great concept in tech that you've probably seen floating around for a while called Yak Shaving. Learned about this last year actually at Google Cloud Next. It's this idea that we all get caught up in it, right? A Yak Shaving is, you start out to do something big and important, and then a day later, you've done everything else but that because there's all these dependencies, right? It's the last in a series of unexpected steps. I read it came from this idea that, rice harvesters were, they would go out to harvest their, the year's harvest, and they'd use the yaks to pull the carts in and out, but they would find that the yak grew all this hair in the middle of the winter, and so they couldn't fit through the gates. So they have to turn around, go back, and do a bunch of yak shaving to get the yak skinny enough to go through the gate, right? And I've heard it said in IT, in tech, this is essentially what our job is, right? Does anyone shave yaks all day long for a living? I know I do. In fact, preparing this presentation, the demos included a lot of yak shaving for me. So much so that it made me an even bigger believer in cloud, to be honest. But yak shaving comes up in all of our lives in different ways. I was throwing a party for my wife last year, and I ended up spending 3 weeks rebuilding a deck, right? You go to buy the electric car, which I haven't done yet, but as you do, you find out that you're now pulling 220 volt into your garage, and it doesn't quite fit, and it's a big bunch of hassle. You say, I'm going to go have children. You have these amazing ideas of graduations and weddings, and it's just, fantastic. And then for 18 years, it's this, and this, and this, and this. And finally, they get tired after eating all the bologna, right? So that happens in all parts of life, and especially as you start to consider a move to cloud. You finally make that decision. A guy like Naidu, as the CIO, says, we got a mandate from our board, our CEO, whatever. We're going to go all in on cloud. We're ready to make this happen. And he says to you guys, make it so. And then you find that, hey, changing infrastructure is hard. There's a lot of yaks that have to be shaved to make the stuff that I comfortably use inside of my data center work in cloud, right? There's specifically in this talk, we're gonna hit some of these issues as it relates to applications that need things like NFS, which seems like a simple, mundane, tried and true method of accessing data, but it's different because everything in cloud is a little bit different, right? I can't just take my NAS and put it out there and work. Doesn't work that way. The fundamentals are different. I need to get my data out there. Well, data formats are different. The files may be the same, but there's different ideas like object and the like. How do I get my data up there, upload it, keep the POSIX nature of the data the same? So lots of other issues come up, and that's what we'll start addressing here today, okay? So we came together, us, Dean and I, essentially in our respective companies, to eliminate those yaks that have to be shaved as you start to make this intro into cloud, okay? We good? So today we're going to cover again a little more theory. Dean's going to come up in just a second and tell you the perspective the Googlers have on NFS in cloud. We're going to show you how some of this stuff works, demo it, and then Naidu's going to be, he's our headliner, so you got to stick around to see Naidu. He'll come and show you the real work that he and his team have done. And by the way, some of his team is out here. We got David and Jonas. Yep, raise your hand, guys. They can't see on the video, but they're in the audience. As any technical questions come up, they can answer it. They're experts. All right? So without further ado, I'd like to hand the mic over to Dean Hildebrand and let him take it away. Dean?
right, thanks, Dave. All right, so I wanted to just give a brief intro on a few things. One of just talking briefly about file in the cloud, and as well as why does Google care about file in the cloud? All right, so here's the typical scenario. A company is going to move into the cloud. All right, this sounds awesome. Google has a bunch of application migration tools. All right, let's move the applications into the cloud. Next step is, well, what do we do with the storage? Are we going to start from scratch? Are we going to rethink, everything we ever thought about storage? Does the cloud solve all of our problems? What are we going to do, right? So I think that this becomes a general blocker in many cases when you have terabytes to petabytes or more data on premise, and you're just not sure on not only where to store it, but how to store it and how your applications will access it. So I think some of the no-nos generally are, right, there is no one thing. So object storage, GCS, it's awesome, and I'm going to talk briefly about it. It's not a requirement by any means. You can't say, oh, I can't move the cloud because my workload doesn't use object storage or something to that effect. It doesn't work that way, right? We want to make sure the matching is great to your application. The other one is we don't want to look at those customers that are on stage. They used, this storage solution. That's the one I have to use. Well, I mean, you could have completely different applications, right? So really, I think we need to ignore all that sort of hype and then think about more just what do your applications need, right? Just focus on the applications that you're running. How are they running today on what the existing systems are, and then what do they need in the cloud? So what can we modernize, and where does innovation and new things make sense, and where does just using what you're doing today make a lot of sense? All right, so GCS, right? GCS is awesome. People always ask, well, why aren't you pushing people into GCS? And the point is that, well, many applications just don't fit the model. And so the POSIX API is one of them, but even if you put the POSIX API on top of GCS, there's still a million other requirements where object storage as a concept in which it's been implemented just doesn't fit, right? As long latency times, no in-place updates, small random reads can be really tricky in terms of how you're doing them. And you can always copy them into the individual nodes and process them there, but if your data set is larger than what you can process in a single VM, you run yourself into trouble as well. So let's go back to think about NFS again and see how that can fit. But talk to some people that are like, well, NFS, I've been using NFS and it's slow. Why are you telling me to use NFS in the cloud? I'm very confused on this thing. Well, the point is that NFS is modern, it is cloud friendly, and it does work really well. There's no reason to dump, baby with the bathwater, as they say. NFS is built into all of the VMs you deploy. It works very well with Kubernetes. It's preemptible, very friendly in the sense that just take your VM away, right? NFS already stored your data somewhere. And in many ways, it's very scalable. It can support tens of thousands of cores, as well as it's familiar to your IT administration staff. And so that's something where we really think we have something that we can build upon. The problem, though, is today, NFS in the cloud, I would argue, is in a very immature place. And we're really just at the beginning of the journey to start thinking about, well, maybe we don't need to do it exactly the same way, and maybe we need to think about it in a slightly different manner on how we're deploying it on-premise, than when we were deploying it on-premise. And so, one of the things is open source storage can be tricky, right? Talk about Yak Shaving. There can be a lot of Yak Shaving in unmanaged open source solutions. The vendor ecosystem is growing, and we're doing our best to improve it, but it's still in its early stages, and that's where something becomes hard because a lot of times you're having to take a new chance on a new vendor inside the cloud. And in a lot of cases, the current NFS and file storage options that you can deploy, they were designed for hardware, and people are just doing lift and shifts into the cloud, and they're not handling new failure models, performance characteristics, and how the durability is managed. And so it's really something where we want to rethink about, let's use NFS, but let's rethink about how we're doing it. So what we want is file storage, manage and scale it just like the cloud does, but drive it like an enterprise, right? We want to make sure that this is enterprise ready. So back to the point of why does Google care though about this stuff, this NFS stuff? Well, let's look at EDA industry. The industry was at $8.5 billion. It's growing over the next 6 years to $14 billion, and that's just the software ecosystem itself. And so that's not including any of the IT infrastructure underneath the covers that's supporting it, right? And so Google wants to be that IT infrastructure that is supporting this multi-billion-dollar industry under the covers, and why we're working with people like Naidu. But that's just one of many industries where we're seeing file is dominant, and the software vendors would have to completely rewrite how they're doing things today. And it's not even clear that it's possible, even if they wanted to. And so manufacturing, oil and gas, higher education research, financial services, those quants that are out there, healthcare, genomics, and media, of course, that you'll see a lot here as well. And so all of these industries are built on file today, and it's something where we believe that if we can make file really easy and well integrated into the cloud, then this is something that Google Cloud can really leverage. And so, our mission here at Google Cloud is to make file storage awesome and easy to use and just as super cloud integrated as you can expect. And that's why we're so excited to work with people like Naidu at eSilicon, who's really pioneering how EDA can be done inside the cloud. And that's what I have. Back to you, Dave. Thank you very much.
Thanks, Dean. Let's hear it.
You don't need
that one. Yeah. I'll take the clicker. So let's, what I wanted to do then is show what this actually looks like and get out of the slides a bit and show some action. And as brave as I am about doing live demos, it's one of my favorite things. I recorded these just for you so we can get straight to the point and cover a lot of topics in a short amount of time. So real briefly, let me tell you a little bit about Elastifile. We're kind of a new company into the scene, came out of stealth mode last year. We built a full stack storage product as an NFS filer, designed to work with kind of cloud principles, but still show up like you're used to in enterprise. The idea that Dean was talking about where you're comfortable living in your enterprise home. Your application is kind of built there, and it exists, and the underlying infrastructure is set. We designed ours to be compatible with that, but also move straight into cloud, and I'll show you what that looks like as we go. So some simple things that we allow you to do. One is just take high-performance NFS applications and run them as is in cloud. All of the semantics work the way that you would expect. I'll show some of that in a bit, but we have it show up inside of Google so your applications can just lift, shift, and start running. Second is we have some capabilities to take advantage of the different types of storage inside of Google without forcing you to deal with it. So there's storage inside of Compute Engine, there's storage inside of cloud storage, and we have the ability to move data back and forth and tier them without breaking like POSIX semantics and a single namespace and things like that matter to your applications. And then lastly, the data mobility side of it, we have a capability called Cloud Connect that moves full data sets. We take snapshots of data and ship them as a whole back and forth so you can keep your data integrity intact, but have it show up and use it where you want it. So think about like giving lift to data sets that tend to have a lot of gravity in them due to the nature of data. So these are the two components I'll be talking about back and forth. On the far side is the file system. This is a full stack scale out file system. So it presents like an NFS server, but it's fully distributed. It's a shared nothing, write anywhere architecture. So as we need to scale capacity and performance, the scaling unit is a node, a little server, and that they just add dynamically, laterally, as you need more, and as you don't need it as much, it just extracts or it constricts back in. So it's very elastic, and it actually works to add and take away on demand. And then in cloud, what's magic about cloud is you can instantiate anything at the drop of a hat. So we can stand up an Elastifile cluster in mere minutes, the kind of thing that you wouldn't do on-prem. You wouldn't stand up a filer on a whim on an afternoon, do a project, and then throw it away. That's typically a 6 to 5 year process, right? That we can shrink it down into a couple of minutes. And then lastly, Cloud Connect is a companion technology as part of our stack. And this is about reaching out to data sets that don't live inside of Elastifile yet. So Cloud Connect can connect to an existing filer, whatever that might be, grab the data, take a complete snapshot of it that's identical to what you have, all of the POSIX data, and the only thing about the namespace, attributes, hard links, soft links, it keeps all that intact, compresses it, dedupes it, and moves it into cloud storage, and makes it ready for action as a file system later, okay? So that's what Cloud Connect is. I didn't take time to add a demo of Cloud Connect into this session. We did one yesterday that was fantastic that I'll show you a link to. And I encourage you to go on YouTube, watch some videos about it, and you can contact us to download and use this tool. But essentially, it's a connection point between file infrastructure and object infrastructures. You know, objects are designed to store files in a flat namespace. So to create hierarchy and logic in an object system, you have to do that yourself, essentially. Whereas a file system shows up and it's ready to go. I can create folders and files, and it all kind of self-organizes. So Cloud Connect bridges the gap between those worlds. Instead of using objects as files, each object is essentially like a block, and then we can store chunks of files across millions or billions of objects and still maintain a namespace, but allows us to take many versions of a file system, as many as you like, and store it in the smallest compacted space possible. So we can do lots of versions of snapshots, compression, and dedupe, and it's a really space-efficient and cost-effective way to store data that you're not really using, and it's also the basis for the tiering capabilities that we have in the product. Okay? So take a look at that. There's a quick sneak peek at the interface of different object providers that it supports. It's really designed to go from any source to any target and be a middleman in between them. Okay, so take a look. This session happened yesterday with Jerome. You can screen cap that link and go watch it. And there's a bunch of videos on YouTube as well. Okay, so let's move on. All right, so inside of Google Cloud, there's a couple of options for NFS. There's a few, and they're growing. And really briefly, being announced just a few weeks ago is File Store. So I'm not going to spend a lot of time on File Store, but it's a fully managed file system. You can get a file system mount, pay as you go, and start using it. It has kind of fixed boundaries in terms of how big it gets, but it seems like a really great product. On our side, where Elastifile really fits is for applications that need kind of really demanding problems to solve, whether it's demanding in terms of capacity or performance or both, and some of that dynamic nature of those applications. So Elastifile is designed to kind of grow with you and just to whatever the boundaries of your application may be. Unlimited is kind of the term that we use and we think about as we design and architect Elastifile. Okay. And it's been great to work closely with the Google team and take advantage of some of the, the power of that infrastructure underneath to really stretch what we can do with this system. So a little bit more about ECFS is what we call it, Elastifile Cloud File System. First of all, like I said, it's familiar. You're going to find an NFS interface that's POSIX compatible. Other protocols we'll probably introduce later to make it even easier for you. Second, it's elastic. Truly scale out, scale in as your needs demand. There's a full API behind the product, so every function that we do, you can automate it behind your automation tool of choice, whatever that may be. It's fast, so we're able to take advantage of whatever underlying infrastructure we attach to. So we attach to raw disks inside of our nodes, and we can take advantage of persistent disk, persistent SSD, local SSD, and even cloud storage, and then take advantage of those and make them available as a single pool of usable capacity, okay? And so that choice allows us to get really cost effective. You can match the storage infrastructure to the cost nature of whatever your problem is and get the right amount of performance out of it. And change your mind. It's, again, instantiate quickly and tear it back down. You can deploy 18 clusters a day. It's all good. It's flexible, so this stuff can show up where you need it. Google is always offering more and more places to compute all around the world. We can follow them around. And then lastly, the last 2 points I wanted to drive home before we jump into the demos. It's cloud native, meaning this was designed with the semantics of cloud in mind. as opposed to that of on-prem, and the world is a lot different. You don't see the infrastructure in the same way when you're running in cloud. The interrupts are different, the failures look different. They're not hardware failures we're dealing with, they're more logical failures in the stack. And essentially you design expecting failures to occur all the time. So there are different principles that you have to bring to the table. We've designed for that. And then lastly, Dean mentioned open source versus supported products. We're a full a company supporting this product, so 24/7 support, continual updates. When you're bringing enterprise into cloud, you need that sort of comfort to be wrapped around it, so everything just works, and you can meet your SLA as we meet our SLA to you. Okay? All right, so getting started, I'm going to show this working. If you want to start, in fact, if you're bored of my presentation, follow this link or go into Cloud Console, look in the marketplace, search for Elastifile. If you can't remember how to spell that, search for NFS, and you'll see 2 options we have up in the marketplace now. We have our file system. Click deploy. As long as you have a project, you can go. You'll be up and running, answer a couple questions, and you'll be able to store data in minutes. And then below that, we're excited. We just released this last week is our storage provisioner. This is our connection into Kubernetes. And so if you have a Kubernetes, a GKE cluster running in cloud, click button, and you're going to be deploying NFS storage to store stateful data from your containers. And I'll show you a bit of that as well. In fact, Jerome's session I mentioned goes into a deep dive on that topic yesterday. Okay, but once you're deployed, you hit our console, runs right out of Google Cloud, and then any application you have that needs this can just start working. All right? Let's show this stuff in action. So demo topology I'm working with today on the top is a project inside a cloud platform. I have our file system deployed. I've got a few standard Linux clients running on CentOS. I have a Google Kubernetes engine cluster running, and that's already deployed. And then I'll be running different applications from there. Cloud Connect connects to object. And then lastly, I have an on-prem data center that's connected through a VPN tunnel to my private project as well. All right, so storage, performance. Everyone talks about performance. I did a couple performance demos for you just to get that off the table. We claim to be high-performance storage and able to meet the needs essentially where you are. So let me show you a couple different profiles I thought might be interesting, and then I'll shift into some of the functionality of how this stuff works out there, okay? So 3 workloads. One's transactional I/O is one type of a workload. You might think databases or lots of small files, lots of changes and the like. Elastifile was designed to be a transactional file system. We excel in this area where a lot of other file systems you would think this isn't what you use NFS for. I wouldn't put an Oracle database on NFS or MySQL or something. Here you can. So the demo I'm going to show you starts here. So I'm running a Kubernetes environment on the top. You'll see I'm going to start adding more and more containers. And everyone that adds, it's going quickly. I'll go back so you can see that a little faster. And then, there we go. So the demos will go quick. So as I add containers and scale them, you'll see performance down here. You got throughput, measured in megabytes to gigabytes per second. You've got IOs, that's how many transactions are happening per second. In thousands, that's a K. And then latency is along the bottom. And then up on the right in the corner, you see how many connections are to the file system. All right, so that's how many NFS connections are being instantiated. So our objective with this is to show you that we can maintain a linear performance profile as load is added to the system. So watch it one more time. Here we go. You see throughput going up. You see this is really an I/O-driven workload. So that hit about 300 or so thousand IOs. All right, let's go to the next one. Second profile, large file random reads. So you have big bulk files. This might be media and entertainment or genomics or something where you have these massive media or image files that need to be loaded up quickly for processing, whether that's for AI or ML or something else like that. We'll show you how we do there. So watch the throughput here. We're trying to get to gigabytes per second. So I'm time-lapsing all of this to not bore you with the details, but this is about 10 minutes worth of loading, and it hits about 5.2 gigabytes per second in the end. So this is a small cluster. This is kind of your entry-level cluster. If we need more, But you see, keep adding more. What do you want to get to? 10, 20, 50 gigabytes per second. We can just keep on going, okay? You'll see we only had 24 connections that were already pushing that much I/O. We're hitting bottlenecks inside of the Kubernetes engine, actually, where we need to keep adding infrastructure to introduce more load to the system. Lastly, the opposite, large file writes. So maybe I'm generating large files, images, and the like. I need to push those quickly down into my storage persistence layer. How fast can I do that? So same infrastructure here. We'll let this guy spin up. You watch throughput again. So as we're adding more nodes, we're pushing up to about a 10 gig connection right about now. So we found we're at 1.1. So that ends up at about 1.2 or so, which is essentially a full 10 gig connection. So we found a saturation point in that network. So that's performance. Everyone talks about performance. You got to perform to play, or you can't qualify in this business. But that's one of many things that matter when you're taking an enterprise application to cloud. All right. So deployments, cloud is typically designed to be click and go and not worried about infrastructure. So this shows you here what a typical deployment looks like with Elastifile. You click on the button, select your project, tell it what network you want to write on, and hit deploy. Okay, you're still using one finger so far, essentially. And then it'll start rolling out. If you've ever used Deployment Manager, it's very, very typical here. All the components spin up. On the far side, or over here, you'll see it gives you unique credentials you can use to log in for the first time. This is our console, or GUI. All of these functions, again, are available through our API. You tell it what kind of storage you want to use. Local SSD, persistent SSD. We've actually just added a few more options to that list just in the last couple of weeks. And in no time, once you hit go, this will spin up, puts a few VMs out there inside of your project, and then those services are now exposed and available to all of the workloads you have running in cloud. Okay, that's it. That takes about 5 minutes, and it's all done. In fact, if you're into automation, infrastructure as code, things like Terraform or Ansible and Puppet, we have options there for you as well. We've got a Terraform, essentially a cookbook out on GitHub. You can go follow that link to grab it, or grab a solution article out of our website on how to do this. In fact, I'll show you in less than 60 seconds here. We'll let this demo go. Assuming this one will play for us. That one is not playing. Let's see if we can get it go. All right. It is so fast, you can't even see it. You're going to see what you would have seen is a lot of code flying through the screen. You give it a cookbook, you tell it what your parameters are, and it deploys it. And when you're done, it goes and destroys it and cleans up all of its mess from before. Okay. Next, the storage provisioner. This is one we're excited about. We just launched this. If you have Kubernetes, which is containers are designed to be totally stateless, but you find that old applications, not old, but traditional apps or in databases and the like, you want to run as containers and get the benefit of compute. They have a hard time dealing with state. You can store data to a local machine, but it's challenging when you get into tens or hundreds or thousands of containers and they need to work off a common data set. This is what we're designed for here, using standard NFS, which comes out of the box, working with a container platform. And this allows you to connect it right into Kubernetes, add a storage class. It will show up as Elastifile inside of GKE, and now it's a resource where you can do provisioning right to us straight from kubectl. Okay. So there's a concept inside of Elastifile called data containers. So a data container is to files and data what a compute container is to your applications. It's a bucket, or contains everything as a file system or a single namespace that you can then manage as a single entity. So a container is where we apply policies to your data. Underneath the cover, things like how much storage does it need. We have services like dedupe and compression built into that. And so this demo will show the creation of a data container. Log into the console. There's your dashboard, all the fancy storage stuff, capacities, performance. We hit the data container screen. You see a bunch of DCs in here. Point and click. Give it a name. We'll be using this one in the next couple of demos. We'll turn on off. You can toggle dedupe and compression on anytime you like. And then we set a size. Okay, there's a dynamic size. But this is what will show up. The file system expects to see a size when you connect to your machine, okay? So that's it. It's created. Get some syntax to connect to it at the standard mount. Again, there's no client-side stuff needed. Standard NFS out of a VM works. So then that's what it looks like. Behind the scenes, you can see the layers of policies of different features we can add in. Replication, snapshots, NFS exports, and other features we'll continually add with our engineering team out in Israel. Will start to show up into here as we continue down our journey in cloud. Okay? You'll see down on the bottom the ability to do user mappings. This is NFS language here. If you're used to the NFS, this is very familiar to you. So here we're going to export this share, make it available to just the machines inside of my private network, and now we're ready to go. That's now being exposed and advertised and ready for consumption. Okay? So let's see it at work. I got a machine, Linux host. Again, the message I'm trying to drive home is this should be normal, right? I do a show mount, and I can see the exported file systems off of that machine. I'm going to make a directory and mount one. Got it. Move into it. There's nothing in there. Let me copy some data in. So standard commands, copying data over. These things can be more difficult with cloud storage. Very easy with NFS. All right, so I'm going to look at a file. So I'm showing file ownership, ACLs. This is POSIX information. File ownership, all of the attributes. We maintain all of that intact. M time, A time, C time, ACLs. Everything works. We just changed it. It's the integrity is there and it just works. Okay? Look familiar? Bingo. Next topic. What about resizing? What if I need to change that? Coming out of storage world, if you've done work in SAN, this is always a big problem. Any block-based systems. The nice thing about NFS is you can change your mind really quickly without really any sort of an impact. So to make the change, either go into the GUI or throw a command through the API, give it a new size. We'd go from 10 gigabytes here to 2,000 gigabytes, update it. And that's already been propagated to the VM. We'll do a DF again. You'll see right on the bottom. We went from 10 gigabytes here to 2 terabytes available. Easy answer to I'm running out of capacity as a problem for the end user. In fact, we can vastly over provision the system. We'll just do this one to be cute. We'll go from 2 terabytes to 20 terabytes. We could move into petabyte range if we wanted to, right? So kind of create your destiny the way you want it, and then you can let your capacity, the actual allocation, doesn't have to be made until you start running out of capacity. So I could have a 3 terabyte cluster that grows into those sizes. Okay? Snapshots. Snapshots are amazing if you use them right in the development process for whatever reasons, restoring files or keeping multiple versions of a database or something. We've built that right into the system here, so I'll show you a manual way to take a snapshot. And again, same caveat, this can all be automated through API calls or other command line functions. So snapshots in place. I think we are on the other demo. Let me skip ahead. All right, I don't have the snapshot one in, but snapshots take. We use a .snapshot directory at the root of every export. So all the snapshots that are taken there are then made available, and those snapshots can then, you can access them and mount them directly, or you can replicate those off to another site like I'll show you here. And the second alternative is to use Cloud Connect to mount a snapshot and move that data to other platforms like GCS. And so a quick sneak peek, if you have 2 Elastifile systems or more set up, we can create a replication relationship, asynchronous replication to other sites. So this would be used if you have an Elastifile on-prem. I can use this to connect through a VPN tunnel to Google Cloud, and I can replicate data up there and make it accessible and the like. Okay? We can go bidirectional and all of that. All right, so there's a quick overview of the tech and all the capabilities in there. There's a lot more than that, but I wanted to, again, drive the point home that we're trying to create a place almost like a hotel experience that's a home away from home as you start to figure out how am I going to get into cloud. So I want to now hand the mic over to Naidu. He's been leading the team over there at the eSilicon for many years, a pioneer in their industry, and they've been, breaking glass as they have figured out how to take advantage of cloud in the EDA space. So without further ado, Naidu.
Thank you, Dave.
Thank you.
Yep. eSilicon is an advanced chip and IP provider for tier 1 system OEMs like Cisco's of the world for high performance computing, networking, data, the AI and 5G markets. So we've been in business since 2000, developed over 300 chips into production. And our current focus is on FinFET, leading edge 16 nanometer and below. Current, the ongoing work is on the 7 nanometer stuff. That is the bleeding edge. And so these, our unique capabilities are, so we are only supplier in the world who is foundry agnostic. We don't care whether it's TSMC or Samsung. We have chips in both foundries. And we use big data to optimize the chip design. Before even the design starts, we estimate big data based on our hundreds of terabytes of data, the IP libraries. So what is the optimal power, performance, and area? So that's our unique capabilities and differentiation in the marketplace. So, Dean and Dave talked about, Google Compute and storage, right? So what are the business challenges that we are trying to address? So in chip design, right, during the tape-out phase, typical compute and storage requirements are 2 to 4x more. So we have on our private cloud about 12,000 cores doing these high-end designs. But one of the chips that required about 30,000 cores 6 months before the tape-out. So about a year ago, we partnered with Google to see that rather than going and building another 20,000 more cores, which is more expensive, we already went into data center as a service about 3 years ago. And there is no capex to build, right? So we are on the OpEx model. But the current issue with the current provider is that every time we need more capacity, they need a long-term commit. That's not going to scale given the technology that we are in 7 and 14. So partnered with Google. And the other challenge we have was, so when you are close to the tape-out, you cannot rewrite your flows, design flows. This takes years. Right? So for us, the current design flow, we built it over 18 years. So it means that within 6 months window, we need to scale from 10,000 cores to the 20,000 more cores. And the last one is that our IP development is always one node ahead. And their compute requirements, again, is exponentially higher to several thousand cores, from few hundred to 1,000 cores. So let's see how we did it. This is a truly hybrid cloud. On our engineers, we have 700 engineers around the world. They come to our data center to do their, the normal flow using the same UI. And so that's why they come to the layout and run their jobs. They don't see anything on the right side. We have configured a couple of queues, 1G internet connection through the VPN for the NFS traffic to the Google Cloud, and 100 meg line for the administrative, like starting the VMs, starting the jobs, and so forth. So one of the attractive things on the Google side was, Google has a concept called preemptible VMs. That comes with no commitment, 80% discount than the regular VMs. That was very attractive to us when we started the journey. And we engineered such that, the chip development is, one of the chips that we targeted this, where 30,000 cores are needed for the tape out, the storage is about 700 terabytes, one chip. So we possibly cannot have that, right? So that's where, the CentOS-based file system over a year ago, it was not scaling. That's when we partnered with the Dave's company, were able to use their Elastifile and, in a hybrid cloud, truly whatever the results are there, locally stored and syncing back to the results to the small subset to the private cloud. The other business unit where we have the the IP development, we don't use any of the local storage. It's completely remote NFS. They are small, thousands of cores. Even now, we are running several thousand cores. Continuously, the results are remote NFS to our private cloud. Again, 90% of the workloads use Google's preemptible VMs. So with respect, Dave talked about, lots of slides, lots of demos. In one project, we were about 8-node cluster with a couple of hundred terabytes, and the other project, 3-node cluster. So it scales. The guy, David, is the key architect on our side, closely worked with the Dave and team. But, so the whole thing took from POC to production deployment. Within 3 months, we were able to scale from 0 to 20,000 cores, one business unit, another business unit, another 10,000 cores within 3 months time frame. So what are some of the lessons learned, during those 3 months POC process? The MDK, the PDKs, and tools, these are all terabytes of data, so we cannot be remote NFS. So we have a local storage on the files in the Google Cloud. The other one is that, on-prem, we are able to, the results, that is where some of the customization is needed. So, terabytes of data cannot be back and forth. Even if you have a 10 gig or 100 gig line, it won't, right? So we modified our flow to only a small subset of the data to sync back to the private cloud. And storage is still expensive. Google knows, and these guys are on the cloud. So we only very aggressive in cleaning up the data rather than keeping it for months. So because the intermediate results are only kept for a week or so, and then the actual results, the small subset, is synced back to our private cloud. Again, the other thing is that the way it stands on the cloud for a chip design, a complex chip design like ours, physical disks won't work. The SSDs, we learned a long way. We started with the physical disk. It wasn't scaling. Then we had to go with all SSDs. And then, like we talked about, right, NFS traffic is on a separate line, and then the administrative traffic is on a different line. These are the key lessons learned. And we are even today, we are the only company that does the full physical design on the cloud. So, yeah, that's it. Thank you.
Take that one. Yeah, I really appreciate that that presentation, Naidu. That was a fun project to work on together. Very impressive what we could do. 30,000 cores, just like that, right? And what are you doing with those cores now? Other great things, yeah, they're being reused somewhere else. That's amazing, right? The ability to stand up an infrastructure that big and that complex in that short amount of time, and then only pay for what you use is pretty impressive. And that's really, I think cloud, from I'm seeing with the customer base out there and different companies, it's just changing the way that you work. Right? The fundamentals are different, so I can do short-term things as needed, pay for exactly what I need, and get really customized. Right? It's kind of a lot of bespoke opportunities in cloud, but it's also becoming a nice place to rest as your final home, if you will, and run applications out there. So I wanted to do a shout out to one of our team members. You don't know him, but you should. His name is Ronan Cohen. He's one of the wizards at Elastifile that did a lot of the work to make these demos come together for us. This is the dress code at Elastifile, by the way. You must wear pointy-coned hats. Lastly, to bring it all back together, no yak shaving, right? Now, I can't say that there won't be any. Of course there will be. That's what we do. It's our jobs. But what we're trying to do is take yet another bunch of labor out of the process to get into cloud, things that really don't create a lot of value, building out file systems and learning how to do ZFS or whatever it might be. It just doesn't add a lot of value to the bottom line when your boss or your business or your organization is saying, I need to get to the financial benefits of cloud, I need time matters, money matters, let's move. We're trying to take those things out of the way so you can move faster. Again, going back to what Dean said, it's not about the hardware and the protocol, right? They're actually agnostic. You can use them in cloud. It's about let's use them the right way and we can move faster. So it's all about acceleration. What we're trying to do is present an opportunity to make it easy to lift and shift or to burst or to move permanently into cloud. And be able to take some of the applications that really demand a lot more than is typical. In my career over the last 15, 20 years, the early adopters in cloud were mostly either pure web applications or secondary storage and DR and backup and things like that. I think the world has really shifted, right? We can do full production, high performance workloads, really intense stuff. And I think cloud is starting to meet not only the functional requirements, but the security requirements to get there as well. So remember Elastifile, cloud native NFS, single click, let it go. follow the link on the bottom in the marketplace, and you can get started today. Thank you. Come see us. We're over in the Moscone South. Stop by. We've got a whole team over there. We'd love to chat with you some more. Okay? Thank you very much.